sine of 3x multiplied by cos of x, right? Minus cos 3x, sine of x is equal to 0.4, right? So that's valid. Okay, so people, when you look at this, and by now we've done so many examples, we've built up what we call foresight. We can say I've got sine, cos, sine. That gives you an idea. This actually tells you we are going to be looking at a compound angle identity. Now, sine, cos, sine happens to be the compound identity for sine, because I've got sine, cos, sine, which is a compound angle identity for sine, right? And then this has to be a minus, so we still use the minus. So this is actually going to be sine of something minus something. That's going to be 3x, and this is going to be x, because that's how the identity works. Do you see here? A and B go there, A and B goes there, sine, cos, sine, and if it's minus, it stays minus. Right. And this is equal to 0.4. We can simplify this further and say 3x minus x gives me sine of 2x, and that's going to equal to 0.4. Right, now we use our QRS methodology. This is positive, so the quadrant that we are looking at is the first quadrant as well as the second quadrant. And now we need to solve for r, which is our reference angle, and that's going to be 2x is equal to second function sine of 0, 4. And once we've done that, we can see that this works out to be 23, 6. Okay, 2x is equal to 23, 6 degrees. And this is going to be our reference angle, 23, 6 degrees. How do I get this? Remember, this part is done on the calculator. Okay, now we go further. The last part is to solve, so I'm going to do quadrant 1 there, quadrant 2 over there. I take the given angle, which is this thing over here, right, which I've solved for there, and I say the given angle is equal to, in the first quadrant, it's just equal to the reference angle, which is theta, 23, 6 degrees, plus n times 360, such that n is an element of z, which I can do at the end. And now I divide everything by 2, and that's going to give me 11, 8, right, 11.8 degrees, right, plus n times 180 degrees, such that n is an element of the integers. Okay, and so we've said n is an element of z. For the second one, again, we take the given angle, make it 2x, and that is equivalent to, in the reduction formula in this quadrant, is 180 degrees minus theta, and theta is the reference angle, which is 23.6, so minus 23.6 degrees, right, plus n times 360, right. So 180 minus 23.6, let's just do that very quickly. 180 minus 23.6. It's going to give you 156,4 degrees. 156,4 degrees, right? Plus n times 360. And remember, this is still 2x. And since that is equal to 2x, we now need to divide everything by 2. And then we get x is equal to, divided by 2 is 156.4 divided by 2 will give you 78,2 degrees plus n times 180. Such that, remember, the restriction n is an element of the integers. Okay, so there's an example relevant to grade 12.